Hi, it's MEC 203 Single Group 47, and here we have the Scooper Rover, short for Surface Cart, for orbital observation and planetary exploration research. To create the design for the rover, I thought of the simplest, most affordable platform that we can start with, and that was a rectangular prism. Pictured in the drawing, the initial sketches featured different designs than the one we ended up with. As you can see, the camera mount and our arm mount are placed side by side, and the solar panels integrated into the body. Now, for ease of manufacturing, the main chassis has the mount for arm and mount for camera built in. Starting with the rectangular prism and using the chamfer feature, I got the main design for the body. The rover now features an elevated solar panel and improved arm assembly design. Paying attention to the wheel subassembly reveals to us a few more details about the rover. For the wheel bearings to connect tightly to the chassis hole so that it cannot rotate, we want to use an interference fit. In this case, we use an H7S6 interference fit with nominal interference of 49 micrometers. Uh, that's true for all of the wheel subassemblies we have here on the rover. Now, if we are to examine the wheel sitting on the shaft, we want the wheel to be able to rotate around the shaft. And so we're going to use an H7G6 clearance fit with a clearance of 46 micrometers so that it is able to rotate around the shaft while maintaining its center. Depicted in this video is the wheels being able to rotate around the axis in which they are placed upon because of the clearance fit that we used. Now, for the solar panel and the chassis, in order to combine them, we wanted to use an interference fit so that the solar panel is not able to move around. And in this case, again, we use an H7S6 interference fit with a nominal interference of 49 micrometers. Next up, we have our camera, which is mounted onto the camera shaft, a part that is integrated into the chassis of our body, and we want it to be able to rotate a full 360 degrees. So, in order for this to happen, we use an H7G6 clearance fit with a clearance of 46 micrometers. And here is our camera having a full 360 degrees range of rotational motion. All right, now we have a pretty big one to talk about here. It's our arm subassembly. So, in order for the arm to be able to move, again, we had to use a clearance fit. And similar to the past times that we have done it, we have used an H7G6 clearance fit with a clearance of 46 micrometers. You might be wondering why we have a lot of H7G6 clearance fits in our project. And that's because we used a standard diameter for any hole size on the project of 75 millimeters. Continuing, the claw piece also has a clearance fit H7G6 to be specific, with a clearance of 46 micrometers, so that it's able to open and close to grab objects. Okay, this video here just gives us a simple example so we can see what it would look like if our arm were to bend down and grab an object from the ground. Taking a look at the exploded assembly allows us to see all the parts that were used to make this rover. Altogether, the Scooper rover prioritizes function over form, but with a design that everybody loves, including the Martians, and being easy to manufacture and affordable. The Scooper rover will redefine the future of surface exploration. Say goodbye, Scooper. Thank you for joining us.